Now let's have another look, maybe with more details, to sphere as an example of manifold, and also we will look for another example of manifold. For sphere, when we talk about sphere, as I mentioned, that we just talking about the sphere of the surface of the sphere, not the volume. So it's 2D, and or D equal to this manifold. It could be defined as we could find a map. For example, if we need to cover all this as the surface of the sphere, we need a chart. Let's suppose that one chart is enough. If we suppose that there is just one chart is enough, that means for each point on this sphere there is a kind of open set around it, or neighborhood, and there is map, one-to-one map from it to R2, to R2. So this sphere could be mapped to this rectangle. But is the question here, is one chart is enough? Actually, because we take open set, by definition the chart is a couple of open set and one-to-one map, the answer is no. Because we have two specific problems. The first, on the pole of the sphere, this pole will be mapped between brackets with a line, which is x2 equal p. And the other pole, the south pole, let's say it's south pole, also will be mapped to the line x2 equal 0. So it's not map. It's not map, because by definition map, one-to-one map, it's not map here. It's not even map. That's why I put mapped, the word mapped, between brackets. Is it the only problem? No, because there is also the semi-circle in the black, which associated to phi equal, for example, phi equal constant. Let's say phi equal 0, for example, will be for each point of this line, of this semicircle, will have 2 points mapped to, and also it's a problem. It's not one-to-one map. Because not even map, sorry. So not even map, and this is so to get over of it, of this problem, we need at least 2 charts. One of them cover all the surface of the sphere except the pole and for example one of the circle, and other will cover this, and there is what's so called intersection between these two open set of these 2 charts. So conclusion, we need at least 2. This is the simplest. For example, simplest example, which could be visuable easily with for manifold. The beauty of manifold is located in the generality. It's a general tool could be used in parameterization. So parameterization, when we say parameterization, what we have finally, the FU, for example, the FU, if we take, for example, two is, as we said, it's coordinate system. So it's parameter. I just take two parameter and I told you where is this point. So the general tool to parameter general tool to parameterize any space, any topological space, and when here we are also we consider differentiability as much as we need it. At any degree we need it also. Until any degree we need it. Other example of manifold, for example, the set of rotation in 3D of any object could be parameterized by just three parameters, which is Euler angles. Also, for example, statistical mechanics, for example, we are familiar with phase space. Usually when we discuss n particle, and each particle has 3 degrees of freedom in position and 3 degrees of freedom in momentum. So we have 6 degrees of freedom for each parameter, for each point, for each particle. So also this phase space is a manifold actually. It's parameterization of, let's say, 3 degrees of freedom. Another example, interesting example, algebraic equation, where is the I have variable y, which is depend on independent variable xi, where I goes from 0 to n. This is, for instance, one of the possible algebraic equation. The set of this dependent parameter y with the other independent variable. Of course, xi is independent with respect to each other, and this set is also described as a manifold. And any solution, any particular solution of this algebraic equation is just a curve in the manifold, which is differentiable also and constituted with this point. For the fourth example of manifold is vector space. Also, vector space is manifold, and we know the definition of vector space. You can which satisfies which is set of points, for example, satisfy certain axioms of vector space. And Euclidean, for example, 2D or 3D Euclidean is vector space in associated with two laws, internal law with an external law. This could be considered as manifold. Finally, also other example of manifold is Lorentz transformation, pure post Lorentz transformation. Also could be parameterized with manifold, and the parameter will be the three components of the velocity of the boost. So this is some example of manifold, of differential manifold, that give you the importance of this identity, which so-called differential manifold in physics in general, and particularly in parameterization problem.